Hi, this video is part of a series in which I learn about programming a retro video game on the Commodore 64 in assembly. The code I'm using is from the game Supernatural, written by Georg Rottensteiner. You may also know the game as Guns and Ghosts. This is not a tutorial, just me learning game programming. Enjoy the video. Hey everybody. Regardless of what I said last time, this is part 15 and the last part was part 14. I don't know. If you've watched till the end, I made a little mistake at the end there. Also, I forgot to show the actual gameplay that we had last time, so I'll start with the gameplay now. And I forgot to show some code. Last time, we added the code to pick up items, and the trick there was that the items used to be painted on the screen, and if you painted them over a platform, the player would fall through. So we needed a way of checking the original screen. So the best solution for that at this moment is to make a backup copy of the entire screen after it's painted and check there. So if you look at the code, I've taken a little bit of the code where we check if we can move up in this case, or and you can see here that the check is actually done against the backup of the screen and no longer the screen itself. So whatever you paint on the screen doesn't matter. You check whether you can walk there by checking the backup copy. So let's have a quick look at what it looks like. In this version, we are going to kill enemies, and when they're all dead, we go to the next level. So you're going to see that as well, right? So don't be alarmed. Don't adjust your sets. So here's the game. As you can see, I'm still the player, still the same level. This guy has 5 hit points. He died in the sky, so I'm not picking him up right now. I'm leaving him there. I jump there and I go 1, 2, 3, 4, 5. Ooh! He killed me. Now, when I walk over this bit. Oh, I picked it up. Really good. I'll have to do that again. Oh, shoot. I'll have to do that again. I'll make it a little bit bigger as well, so you can actually see. 1, 2, 3, 4, 5. Still in the sky. See if I can... Oh, I died. It's actually become a video game now. 1, 2, 3, 4, 5. Darn it. That's funny because I killed it. See that? I killed it. But it didn't spawn anything. Okay, see that? There's a wait before I go to the next level, and now I go to the next level. Now there are some bugs because actually in the top right, top left corner. Oh, hey! Now it paints my. There are some bugs in this code. See, I'm not falling. I'm not falling. That's what I wanted to show. 1, 2, 3, 4, 5. Now this code has bugs. You can see that in the top left corner, a little black box appeared that is supposed to show the number of enemies, but that is in the part 15 code. In part 14, the thing is, we have these objects. I can pick them up, but you can see there's bugs. I'm not falling through the floor. That is part 14, right? So I'm picking this up, and the original floor is reconstructed. I can even have items overlapping each other, it'll handle that as well. I picked that up. The jump table bug still hasn't been. I can only fire left and right, not up. So, well, that's it. That's what I'm gonna show. Let's look at all the code that's gone into to do that. As per usual, I go down to the data, and I show you that we now have a number enemies alive, which is a byte long. So we can have a maximum of 255 then, or 256. There's a level done delay, and there's a delayed generic counter. Now, I'm not entirely sure why this method was chosen, because this is used, as we'll see, as sort of a gateway to... This waits a number of frames before a timed action can take place. The thing that we're trying to achieve is that at the end of a level, we don't jump to the next level straight away. We wait and then jump to the next level. So that's what we're trying to achieve. We achieve that by waiting 20 frames. But this delay generic counter makes it so that we wait 8 times 20 frames. That's 160 frames. It's still something that we could have done in a single byte, but there may be other things in the programmer's mind here. So that's been added. That's the only data that we've added. I'm going to take you now to the main game loop. No, let's go to the code that comes before the main game loop, because something's changed there. See, this is all the start code, and now at this spot, the last time, I might even be able to show you. If I'm gonna check the previous version of the code, I have it here. Or set sprite flags. Just looking. Oh, maybe I can make you a part of what I'm doing here. Right. Set multicolors. Right. This is where the sprite 1 position. The sprite 1 was treated differently. You know, the position was calculated, blah de blah, everything was done. But the weird thing is that, that the player is actually just an object, right? We could treat it as an object, a special object, but it's still an object. So in the previous version of the code, it looked like this. In the current version, this is all gone. So the init sprite code has been removed for the player. So what's happened to it? Where is it gone? We'll see that actually it was already in the code, or at least in the data the last time. I'll show you what it looks like now. Also, we've removed all the code that copies this level to the backup buffer. We've just made a function out of that. And but this is all demo stuff. In the top left corner, we are adding a number. Now, I cannot just keep a byte that says value 1 and write that to the screen, because I have to convert that value into the PETSCII code for a number. And I have to add 48 for that in this case. So we clear the carry and then add the number play enemies alive, which starts out at 0, and then we draw that on the screen and we make it white. That's what happens. But we do that after the build screen. Now, the build screen is changed, obviously. Let's go back to the data of a level, because I didn't show you this yet. This table, when we go to the start of the of the level data, this used to have just one level. Now it has two levels. This screen data table was a table that lists all the levels that we have. So our level number is an index into this table, but you have to take into account that each element in this table is a word, which means 2 bytes. I mean 2 bytes. 2 bytes, sorry, 2 bytes. So we have to translate the level number into a correct index into this table, and it gives us the address of the actual level data, which is this. And I added a remark. Hello, what's that? That's the player. The player has been added as an object. And just to check whether or not I was crazy or not, I went back to the to the previous version of the code, and I missed it completely, but it was already there. It was already there. So I must have been sleeping last time, but the player is there, and it must mean that the build screen code has to take that into account. And it does. So, but we'll see that later. Let's go back to the main game loop here and see what's changed. We have a game flow control. Yuck. Semantically, I don't agree with this choice, and it may seem like I'm nitpicking, but I'm not, because these are the things, when you're a programmer trying to read this code, which could be yourself in a future time, reading your own code, and you think, what the hell did I mean by that? Game flow control, I guess, the code determines the flow control. Design-wise, I wouldn't say, I couldn't write a function that controls the flow of the game. That's the entire code. But, it's a new function. What does it do? It does control the flow of the game in the sense that it waits at the end of a level. Now, here's the delay generic counter. It starts off at 0, and this is called every frame. So the counter is increased, it's loaded compared to 8. If it's not 8, then there's no timed action yet, and we jump out. If it is 8, then we reset it back to 0. So it counts up to 8, 0, 8, 0, 8, 0, blah, blah, blah. It does it every time. And every 8th time, we say, hey, how many enemies are there alive at this moment? If there's still live enemies, then we're not done yet, and we jump out. If we are done, then we increase the level done delay value. We load it, check it for 20. If it's reached 20, then we go to the next level. If we don't, we go to the next frame, and we go through 8 iterations of this, and then we increase this one. So you get 8 times 20 frames, and every so many frames. I can't do the math so quickly. Every 8 frames. Yeah, every 8 frames we increase the border color compared to 20, and if it's 20, we go to the next level. If it's not, we increase the border color, and then we're done. So we go to the next level. Next level means that we disable all the sprites. We have to do that because a new level may have different sprites. We increase the level number from 0 to 1, which is funny because oh, wait a minute. Yeah, at the end of build screen. Then we build the screen, and then we copy the current level that's just been built to the backup buffer, and we're done. Now let's have a quick look at build screen, because I'm becoming interested in what that does. So build screen. Yes, there are changes. We set the number of, we're building a new screen. So we're reading the data and painting it on the screen. So first we say, well, let's initialize the number of enemies alive to 0. And let us, and we do the level done delay as well. Then we start resetting all the objects. So we set all the sprites to inactive. Do that for all the sprites. And then we clear the screen. We did that. This is the same as the old code. And then we have to read. Last time we just had one level. So, all we had to do was read that level. And we were done. Now we have to take the level number. We have to multiply it by 2 because index 0 is just has to have access to indexes 0 and 1 into that table, and level number 1 has to have access to 2 and 3. So 1 is shifted left. Shift left means means multiply by 2. Did I say divide? I don't know. I'm sorry. I meant multiply. Sorry. Excuse me. So we multiply the level number by 2. We transfer to X because that's our index register here. And we get the correct table entry. We get the high part first, then we add 1 to get the low part. And this is where we wrap around to 0 if the last entry into the level data, into the screen data table is 0. So if the high part of our level address is 0, then we're pretty sure that we've reached the end of the table. So there's no more levels. Go to no more levels. We just set the level number back to 0 and build that screen. Build screen. Build screen? Jump to build screen? Jump to build screen. Oh, we jump to ourselves. Oh, that's funny. Okay. No more level. If there isn't, then we go to build level. Build level is just the old data, the old, the original code. We go there, and then we come back and draw the border. Oh, and we point the 0 page pointer at the border data and call build level again. So this function is called build screen, but it has like sub functions. Like build level is a sub function inside this function. So it does all that. It doesn't even it picks up the level data items as well as objects. And if it's an object, let's go to the object. Does nothing weird. Just find empty sprite slots. I wonder, because if we are the player object, it is now the first object in the list, so it's going to find the first slot empty. It's going to put us there, but it may not be there always. But does it have to be? I don't know. Initialize enemy values, sprite player. Oh, look at that. Sprite direction. See, these are the tiny little things that can go horribly wrong, and you won't be able to find them later, because here, sprite player, okay, we get the data of the we put that in the sprite player, that's the location, and you put that in the pointer, but we put it. Oh, look at that. X can actually be any, so the player doesn't have to be the first object anymore. So that's a pretty big thing, If you didn't, or if you sort of secretly took into account in your head that the player was always going to be the first sprite, which we saw did happen quite a few times, this code may actually place the player into a different slot, making your code behave weird. And as we've seen the code is behaving weird, because what's happening is that if I don't pick up an item and I go to the next screen, at some point all of the items are going to be painted again. So that's definitely a bug, but there's just no code for that yet. When we move to another screen, we have to remove or we have to clear all the item data as well, which isn't being done, obviously. The code here, we check if we are excuse me. We check if we are drawing an enemy. If we are, then we just increase the number of enemies alive. For some reason, I'm expecting there to be a little... No, this is actually working, because after we've killed all the enemies, we do move to another screen. Just the value in the top of the screen isn't being displayed correctly, and I think that has to do with the fact... If we just search... Sorry, I'm scrolling about, which is a bad idea. I've number of enemies alive. I'm just gonna select this, and I'm gonna find... Oh. Okay, this is where we add the number of enemies alive to 48. Find next. Okay, we just load it here. We decrease it here. This is where it goes wrong. See that? Oh, no, number of enemies alive. No, it's still okay. It's just... This is drawn before... it's done once correctly. But it's not drawn again, is it? Screen character, where... We do see a block appearing, but the game never returns to this code, so this is where it must go wrong. At some point it does draw something. It decreases, but just this number should be... This should be done in build screen, shouldn't it? No, how is it updated? How is it up? Is it drawn? I wonder. That's a good question, isn't it? Build screen. Number of enemies alive. That's nice, but it's not being redrawn. It's not like we're constantly redrawing the entire screen. I'm just flicking through the number of enemies. So somewhere this value should be red, but I'm just wondering, because if we play the game, see, it's 3 now. 1, 2, 3, 4, 5. It updates. How does it update? It's when I kill an enemy, isn't it? Let's see. Enemy killed. Where is that code? I'm gonna have to search for it. Enemy kill, and I'm glad I know the name of that function. Enemy hit. Enemy killed. Decrease number of enemies alive. Oh, decrease screen character. Right. So, yeah, I think having that value on the screen seemed easy, but this is where it's decreased. But it's just, it's it's decreased, but just setting the value correctly. But decrease screen character. This is the only place where I'm gonna search for it again for screen character. So this is like a quick and dirty way of drawing to the screen. This is where that's drawn. We put an item image. Yeah, that's used. We decrease it, and that's it. Okay, well, it's not really important. Okay, and I think, therefore, I am. I bet you didn't know that. Let's just see if I found any. Yeah, that's gone. We've had that. We've talked about that. There's a new function call. We did that. We did the game flow. Go to the next level. Yeah, we did that with the weight thing. Go to the next level. Build screen. Copy to buffer. Yeah, we did that. I'm just scrolling through all the code here. Going down. Going down. Going down. Let's click on something here. Oh. Just checking the time. We're on 25 minutes now. Going down, going down. See, the code has become quite extensive. Enemy killed. Get the type if it's an enemy. Yeah, we decrease the number of enemies alive and the screen character. This leads to our small bug. Remove the object and spawn an item. That's just all existing code. And I think that's it. Yeah, so there's lots of tiny little things to take into account, and sometimes things look easy, but they're not. And just, the length of this code, I'm scrolling through the entire body of the code, and just the fact that it's all in one file is starting to work against us. Did we have this? Yeah, we had this. So we had the build screen. Yeah. Because if we're not really intimate with the code, we have this, which you probably can't read, but we have this to navigate the code. This is in order of appearance in the code. And if you don't do your zones exactly right, I'm not always going to feed, because the enemy killed code, where is that? Where is enemy killed? I'd have to open all of these things. It's just better to search for it. But when I get to the point that I have to search for a term in the code, then I'm really looking. I've lost my way. And the weight frame stuff, remember that? We did this at the end. It's funny because if you do a debug and you pause the code, 9 out of 10 times you're going to end up in this code. So busy waiting. That's what I said at the beginning. When we're just standing there not doing anything, the code is busy waiting all the time. And if you're the only process on the system running, then that's okay because you're hogging the CPU anyway. But if you're sharing the CPU with other processes, then busy waiting is really arrogant. Our random number generator, remember that one? Some of this code hasn't changed in a long time. But at some point, we're going to see that this jump table, this has a value in it, number 8, that's not being used. And I can fix that by shifting all this to the right one bit, and then we have a higher jump. But this 8 is not used. And at some point, we're going to see that the program, that Georg finds this error, and we'll probably fix it. Hopefully. Okay. That's it. I want to thank you for watching. This has been part 15. And I'm going to take a little break because it's my holiday, and I'm not going to be around to do this. So it'll be about 2 weeks before there's a new one. But hang in, and I'm sure you got other things to do than to listen to me going through this code. So thanks for watching, and I'll see you in the next part. See ya.